Hey guys, welcome back to General Chemistry. Up until this point in the chapter, we've talked a lot about how important electrons are. We've talked about electron configurations, orbital diagrams, abbreviated configurations. And that's kind of all leading us to this pinnacle moment, to this moment and the presentations that follow. So the most important part about what we've been talking about is being able to quickly identify valence electrons. So I told you guys in a previous video that valence electrons are the electrons in the highest energy level. So whatever energy level is being filled, the highest one, that's where the valence electrons are. And I also told you that valence electrons are the only electrons that are available for bonding. So when we start thinking about how things bond, we need to very quickly and effectively identify valence electrons. So we're going to use some tips, tricks, and tools to quickly identify valence electrons and then talk briefly about predicting ions. So what? Entire chapter about electron configurations. Also, why are properties in our periodic table so periodic? Why do we see trends repeat every 8 elements or so? How do I know that the S group and the P group are predictable and the D group is not predictable? All of that is based on electrons. So first, predicting valence electrons. So what you see here is a portion of the periodic table. So here's group 1, group 2. In this split right here, that's where our D block would go. So I basically removed the D block and pushed S and P closer together. So I would jump over that gap of the D block, and now I'm over in the P, and I finish off in my noble gases. Okay. For the S block and the P block, I told you guys that these are very predictable elements. And here's another example of how predictable they are. The numbers at the top of each of these families, we call them families because they have the same traits going down. The numbers at each of the top of these families will quickly tell us the number of valence electrons. So anybody that's in group 1A, they have 1 valence electron. Anybody that's in group 2A, they have 2 valence electrons. Jump over the D block, 3, 4, 5, 6, 7, and 8 valence electrons. So for those 2 groups, if we just look at the number at the top, it's going to tell us. Often you will find these guys written instead of as 7A, 8A, so on and so forth. Sometimes you'll just see them written from left to right, and these end up being like 13, 14, 15, 16, 17, and group 18. You can still predict the valence electrons. Just essentially put your finger over the 1, and it'll tell you how many valence electrons. So in 13, there's 3. In 16, there's 6. 18, there's 8. Okay. This is going to help us to predict ions. So this is a skill that I am introducing to you now. We're going to perfect it in the coming chapters, but I always like to introduce now, perfect later. So if we can predict valence electrons, that's going to help us to predict what sorts of ions form. Now let me remind you what an ion is. Ions are charged particles. So we have varied the number of electrons. We've either taken electrons away or we've added electrons into the mix. So that's how we create an ion. Up until now, I've told you that, hey, this atom is going to lose this electron, or hey, this atom is going to gain electrons, but I never told you why. Here's a why. Let's look at the electron configuration for chlorine. So chlorine is right here. So the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4, 5. So here's the electron configuration for chlorine. I asked you guys to predict, if I asked you guys to predict the number of valence electrons, you now have two ways to do that task. You could say, oh, look, chlorine is in the 17th family, so it's going to have 7 valence electrons. You could also look at the electron configuration and say, oh, look, the third energy level is the highest energy level, and there are 2 plus 5 in there, so 7 valence electrons. Electron configuration can also help us with another thing. The noble gases, these guys right here, they are the most stable atoms on the periodic table. They are the cool kids of the periodic table, and everybody wants to be like them. How many valence electrons do they have? They have 8. Every other element on this periodic table is going to beg, borrow, steal electrons so that they have 8 electrons in their valence shell. So if we're looking here at chlorine, chlorine has 7 valence electrons. He so desperately wants to be like argon, who has 8. So what chlorine is going to do is he is going to steal 1 electron from somebody else. He's going to add that to his configuration. And now his configuration is going to look identical to argon's. He's going to have the same stability that argon has. So when this happens, chlorine will steal 1 electron. That electron will go into that P sublevel. So there's one more space open. We put that electron in that P sublevel. And now his electron configuration looks exactly like argon's. He steals electrons. Okay. Let's look at sodium. Electron configuration for sodium. So here's our sodium. We have 1s2, 2s2, 2p6. We're in the 3s block, and we're putting 1 in there. Okay, so that's the electron configuration. Now, sodium also has a desire to be like a noble gas. He could move all the way forward to be like argon. But what noble gas might be a little bit closer? Yeah, what if we go backwards to neon? Doesn't matter which noble gas we want to be like. We're just trying to be like any noble gas. So what sodium does in order to have 8 electrons in his valence shell, sodium says, you know what? I've got 1 right now. I could go out and try to steal 7 more electrons to fill that up. That sounds like a lot of work. Or I could just give this one away. I could just give it to somebody else. Somebody like chlorine that's looking for 1. I don't know. But I could give my valence electron to somebody else. And if I do that, now let's look at the electron configuration. So now we have no need for the third energy level. There's no electrons in there. Now what's the highest energy level? There's the second energy level. And is it full? Does it have 8 electrons in it? It does. And that's what we're looking for. That's stable. So when sodium becomes an ion, he will give away 1 of his electrons. That will bring him down 1 energy level, but that's okay because that energy level is full. It has 8 valence electrons. So that's an introduction to predicting valence electrons, and then one kind of quick application. Again, this is a skill that I'm just barely introducing to you guys. We will perfect it later on when we get to chapter 4 and we start making compounds. I hope you guys found this helpful.